Welcome to Maths Video 25 on navigation. Section 1 is on compass points. There are four main compass points, also called cardinal points, and they are north, south, west and east. Between each of these main compass points are northeast, southeast, southwest and northwest. You will see that we always name the north, south before the east and the west. Between these there are further points such as north, northeast, again mentioning the north first. You need to remember and know what order these compass points are in, and there are a number of ways of doing that. My favourite one is naughty elephants squirt water. Another one is never eat shredded wheat or never eat soggy wheat bix. Or you can just remember that reading across from left to right, we makes a word, but EW is actually not a word. Between each of the main compass points, such as north and east and south, is 90 degrees. And between the ones in the middle will therefore be 45 degrees. So north to northeast is 45 degrees. Let's have a look at an example. If someone is facing east and turns 270 degrees anti-clockwise, what direction are they facing? Well, this is east and we're going in the opposite direction to a clock because anti-clockwise we're going around this way. So that's 90, 180, 270, they'll be facing south. You'll notice that that's the same as actually 90 degrees clockwise, because the difference between clockwise and anti-clockwise will be 360 degrees minus the 270. Directions. Compass points are most commonly used to provide directions. Let's look at an example. Walk 3 squares north, 4 squares west and 1 square south. What square do you end up on? Well, north is always upwards at the top. Any map, north is always drawn to the top, whether or not it is actually designated. So I'm walking 4 squares north, so I will simply go 1, 2, 3 to the O. I'm then doing 4 squares west, so I'll go 1, 2, 3, 4, and then 1 square south, and I'll end up on the square here, which is P, and that is my answer. Speed. What is speed? Speed is the distance travelled in a particular time. How fast something's going. Speed can be calculated using the formula speed equals distance divided by time. That can also be written as S equals D over T. We know this because, for example, we'll talk about 20 kilometres per hour. That means in each hour, per meaning each, in each hour we're travelling 20 kilometres. Therefore, if we travel 40 kilometres in 2 hours, that's over 20 kilometres in 1 hour. So that's distance divided by time. The units for speed can be miles per hour, which is written as mph, kilometres per hour, which is kilometres/h, and metres per second, which is m/s. It's important that miles uses a p and kilometres and metres do not. Otherwise, miles per hour and metres per hour would look exactly the same. Example, if a cyclist travels 25 kilometres in 2 hours, what is the average speed? Well, we start by writing our formula, S equals D over T, or speed equals distance over time. Then we replace our symbols with the numbers we have in the question. So distance is 25. So instead of D, we write 25, and our T is 2. So that is 25 over 2. And then divide that, which gives me 12.5 or 12.5 kilometres per hour. Let's look at another question. If a car travels at 30 miles per hour for 8 hours, what distance will they have travelled? Again, I write my formula, and then I replace the numbers that I know. This time I know that speed is 30, and that time is 8. Now this is an equal sign, so whatever I do to one side, to the other side, I do exactly the same. I don't want D over 8, I want just D. How do I get rid of the over 8? I times it by 8, because 8 divided by 8 equals 1, leaving me with just D. But whatever I do to this side I do exactly the same. So I'm going to multiply both sides by 8. 30 times 8, I can delete each 8, cancel them out, leaving me with just D. And that means that D will equal 240 miles, 30 times 8 being 240. Distance time graphs. Distance and time can be plotted on a graph, with time on the x-axis and distance on the y-axis. If it's a straight line, a horizontal straight line, it means that it is stopped because time is still increasing but the distance is staying the same. A straight line going up means that it's going at a constant speed because as time goes by, it's increasing at equal amounts of distance. And the steeper the line, the faster the speed. So this blue line here is going much faster, this red line here, because in the same time point, you've travelled further. You're doing more kilometres per hour, or in this case, more metres per second. We can use the distance time graph to describe a journey. For example, here, you will see that it's going at a constant speed for the first 20 seconds, then it's stopped at a constant faster speed for the next 20 seconds, and then it returns. It's going in the opposite direction, going back to the start. We're finishing at the same place as we started from. I can also calculate speed from a distance time graph. For example, calculate speed at 5 seconds. Well, if I look here, at 5 seconds is in here, and we know this is a constant speed. So I can use any point along this line. Speed equals distance over time. So I'm going to read my distance and my time. Well, over this part of the line here, my distance is 10 metres and my time is 20 seconds. So I replace distance with 10 and time with 20, giving me half a metre per second. Similarly, if I looked at this part here, speed equals distance over time. Well, distance here goes from 10 to 40, so that's 30 over the same 20 seconds. So that'd be 30 divided by 20, which will be 1.5 metres per second, 3 times faster than this one here. Bye for now.